Okay. Nobody knows about antigen. What is antigen? Very good. These are the foreign objects which induce immune response. Fine. Very good. So what are the characteristics of it? Is it necessary it should be foreign only? Then why everybody is writing foreign object? Okay. Whether anybody knows about hapten? Somewhere studied what is hapten? Okay. Fine. I don't know whether you people are having that habit or not. Should keep notebook simultaneously. This is what my expectation is. The things which you do not know, you note it down, search it, and answer it to me. Okay, what is hapten? What is antigen? I want good definitions. Okay, let us go ahead one by one. Now we'll start with our this one. So we know what it is. Okay. Now, once you understand this, what is protect host from harmful foreign objects, we have seen. Allograft introduction can elicit damaging immune response. Allograft introduction means anything which is grafted or tried to put into body. We have seen these two things, cellular and humoral mediated. These are the pathways how they are taking place. And I told you earlier also that I read in preface in the beginning of one book that immunology is okay, Akash, but then what importance they carry? I want to know what is happening and okay, whether they have any role in immunology. Let me understand. Okay. Now these are the ways how it takes place. So there are so many chemicals are involved to what to that we call as a cytokines, chemokines. Okay. Then output of it, these are we have seen as a prostaglandins, we have seen as a leukotrienes. Then there are various interleukins. So there are variety of chemicals which are involved, and these chemicals, they are participating in variety of reaction that includes cellular or humoral or combination of both, either any or both. So basically how it happens is uh, how these macrophages they engulf, particularly there are then APCs are present, that is called as antigen presenting cells. Lymphocytes they are participating, and there are uh, various other lymphocytes like beta lymphocytes, then MSC class peptides, major histocompatibility. MSC means class 2. So these all are causing various complexes. Is very very complex actually process, and too many chemicals are involved. And that's why I asked you to go through the physiology in more details, because this is all physiology part, this is not pharmacology. So we should understand the role of these chemicals. So these interleukins and various chemokines, they participate, and because of these participations, I told you earlier that is in a preface I have read that it is invention of a devil. So it has got a very big vastness, immunology as such. But at least you should be aware about what happens. What do you mean by CD cells, CD4, CD8, their counts? These all are see, they are important in binding of the antigen molecule, and because of binding of that antigen molecule, antigen antibody complexes are there which are either engulfed or other reactions are being taken. So this is a very big picture. You can see various many kind of uh, these cytokine chemokines and things are working on that. At interleukins are there, as I told you, interleukin 1, 2, 3 up to 10 are there. Then interferon gamma is there. Okay, then TNF alpha, that is tissue necrotic factor beta, is there. Then you can see the you can see uh, these activated cytotoxic T cell because of this various actions. So all these chemicals are there which are acting, and these are responsible for that. Here, these are the beta lymphocytes which are differentiating because of the actions, and they are causing formation of various immunoglobulins like IgG, IgM, IgA, IgD. So this is what different kind of immunity is there. So this much part is cellular immunity, and the next one portion is the humoral immunity. So these things are there. If we in basically in pharmacology, most important thing is we should be aware about various basic causes. So what is physiology, what is pathology, then we understand how to treat it. Until and unless we are aware about the physiological role, physiological mechanism, uh, it will be complex one. Okay. Then what are cytokines? As I told you, these are soluble antigen non-specific signaling proteins that bind to cell surface receptor variety of cells. They are interleukins, interferons, TNFs, that is tumor necrosis factors, then TGFs, that is transforming growth factors, colony stimulating factor. Colony stimulating factor recently we have seen. Okay. Can anybody tell about colony stimulating factors? Where we have seen colony stimulating factors? Yes, the erythropoiesis and other colony stimulating factor, GM-CSF and GCSF, MCSF we have seen. So these are all there. And it is, a big mechanism actually. That is, there are simultaneously, when we say again immunological reaction, it is a cascade of reactions. Simultaneously, many things are happening. Okay. Simultaneously, new cells formation is there. Therefore, colony stimulating factors are required. Then tissue is has to be repaired. So there you need the transforming growth factor like there. Tumor necrosis, there are damage of certain cells. That cell has to be removed. Okay. So you need such kind of necrotic factors, interferons, which controls, and it is all complex mechanism uh, that is happening, that is taking place. So the immunology therefore is a very complicated mechanism. It's not simple that you have got some beta blocker last year, beta 1 blocker acting on heart. It is specific beta 1 blocker and done. So it is not the case, and therefore so many things are involved. One has to be aware about it. So what are their roles? They causes proliferation of antigen primed, that is helper T cell. In cellular mediated, that is the Th1 that will produce more interleukin 2, TNF beta, then INF, that is interferon gamma, they will active NK, that is natural killer cells. Okay, NK is a natural killer cell. They will kill tumor or virus infected cells. Okay, you understand now. It is just like suppose some building has got a problem. There is a narrow road, then you have to first that building has got, because of that, the what's your building material is there, it is there on the road, and until and unless it has been clean, nothing can be done. So all these participants in different thing. Okay, so they will kill tumor and virus infected cells, cytotoxic T cells. They will kill uh, tumor and virus infected cells, macrophages. They can kill bacteria. So these are the variety of cells. They will causes engulfment of the cells, and because of that, these cells will be destroyed, so that now new material can be built. For that, these mechanisms are there. Okay, so this is what same picture. Now we are enlarging that how this interleukin 2 and there they are acting on thymus or T, one type of cell, and then how differentiation takes place, activated macrophages, which kills. Then this is all we call it as a differentiation. That from one cell, three different physiological activities or three different type of cells are there. The natural killer cell and activated cytotoxic T cells are there. These are produced, and these are various chemokines, cytokines which are playing role. Humoral beta lymphocytes. Okay, they are TS2. They are producing interleukins. That is interleukin 4 and interleukin 5. They causes beta cell proliferation. They causes differentiation into it. Differentiation into two types of cell. One is uh, memory cells, which will keep the memory, where genetic material for the previous kind of exposure will be kept, and another will be antibody which are secreting the plasma cells, which will be able to secrete the antibodies. Okay, so this is how, again, wider picture. If we see, this is there how this from the T cells, that is, or thymus type 2 cells, we can have, that is interleukin. Karthik, I have tried this time, but always may not be possible. Try to be in time. So these are the proliferation will take place, differentiation will take place, and accordingly it will produce various antibodies. Okay. So there is a mutual regulation, means in between there will be mutual regulation between both type of cells. So Th1 will through interferon gamma, it will inhibit Th2 cell proliferation, while Th2, because of the interferon 10, it will inhibit Th1 cytokine production, so that one type of activity will be more dominant as the case require maybe. Now, next thing is that this is what basic physiology. When we say that it is basic defense mechanism and it is good for the body, then why you want immunosuppression? Have you used immunosuppression somewhere? What is need of immunosuppression then? Okay, only organ transplantation. Yes, Akash, they suppress immune response, but then why you want to suppress immune response? If you say that it is body defense mechanism, if you say that it is good, then why you want to do it? Autoimmune responses. Again, or any other thing you have thought about? Any other immunosuppression drug you have encountered earlier? Glucocorticoids. Where you read it? Have you studied glucocorticoids somewhere? Have you studied methotrexate somewhere? I do not having any objection if somebody is simultaneously parallelly searching on a mobile or Google. I don't mind, but my question is just give some stress to brain also. Whether anybody studied glucocorticoids earlier in COPD? Why you have studied it? What was its mechanism of action in that? Hmm. Okay, okay. So when I was telling about this, why you need immunosuppressant, you have some reasons already. You have seen this reason. You in bronchial asthma, you have used anti-inflammatory agent in severe inflammation. Why you are using immunosuppression immunosuppressant drug in inflammation? What is the reason? Why you want to suppress inflammatory response? So, and what it has? Is there any relation with immune mechanism and inflammation? Definitely, inflammatory responses have to be suppressed. Therefore, you are using. But then, why immunosuppressant? Why not other agents? That's why it was important to learn immunology before starting this chapter. That inflammation is always an outcome of immune response. Okay, whenever there is a any kind of immune reaction, then only inflammation can take place. That means during inflammation, always immunological role is there. Okay, it may not be hyperimmune response. So when it is not hyperimmune, but still there is inflammation, that means without affecting our immune mechanism, it's not like that, Prerna. Okay. Again, I hope definitely you must have read pathology of this bronchial asthma. Two theories are proposed. Hmm. One is inflammation theory and immune theory, and it is said that it is both are working hand in hand to cause asthma. It's not one after other. Okay, so both are working hand in hand, and therefore it is there. So simply, I wanted to tell you one thing is the inflammation is outcome of immune response. Okay. Now, uh, it can be milder one because if small tissue injury is there, still the cytokine will flow to that, and because of all these cytokines, they will whatever role they will play, the outcome will be inflammation. But now here there is no foreign object, no foreign, but the tissues which has been broken down, the debris we call it as a that has also initiated the immune response because this is. Have you ever heard the word chemotaxis? and why there is a movement, not only macrophage, many, including even other WBCs, not only macrophages. And why this they movement? Who who initiates them? Who initiates this movement? What is the reason behind this movement? All of a sudden, why they start moving to that area? Means what kind of concentration gradient, Sanika? Just like drug from higher concentration to lower concentration, isn't it? Just like drugs that goes from to lower concentration. Now you are confusing me. The gradient must be either increasing or decreasing means what? Gradient is gradient. Then that means you have not taken my words seriously. No one has read. There are many agents to them what we call them as a chemotactic agents. Okay. Now again start searching chemotactic agents. Don't do the now. You concentrate on lecture and then do whatsoever you want. Okay. What are chemotactic agents? These chemotactic agents, they invite the cells to that area. They do the job of repair. They do job of vasodilation. Because of that, there is inflammation. So inflammation always follows either milder or even mildest type of immune reaction, but it is there. Okay, that is very simplest story behind it. Okay, in that case, we are going to. There are many conditions where we have to use immunosuppressant drug because we want that the immune mechanism should not affect there, because just like cars are there, uh, the cars are moving and somebody applies brake but still it skids. Okay, so same thing like that. When immune mechanisms that take starting, sometime it goes overboard. That is, they are not understanding what, or just like if you have seen any Olympic or such kind of races, then after finish line you'll find that the runner is still moving faster. He cannot stop exactly. I have finished the race and now I'll stop here only. So similarly, when the mechanisms have started, it can go and sometime it can go overboard. And once it goes overboard, during that we have seen that there are cells which are killer cells. So even these cells sometimes they cannot identify exactly, just like we have seen that they causes engulfment of natural killer cell or other kind of cells. So these cells, they may not able to identify it properly and they go on destroying the cells. So they can even destroy the normal cells. So this is actually the problem where it has to be encountered, because because of immune reaction many things can be there, because we have seen many participants in that. There are growth factors which are there. So sometimes growth factors, if they are coming too much, then it can cause too much tissue. So too much tissue itself is also a problem. So too much tissue itself is also problem. So in that cases, uh, we want to have a control that it should not go too much. It should not affect. and therefore we are using. And definitely there are, as we have seen, autoimmune disorders. We have seen the transplantation or graftings, tissue grafts or such kind of grafts. So there are many such things are there which causes or which requires the use of immunosuppressant drugs. So what are these? These are first are inhibitors of cytokine, that is uh, interleukin 2 production or its action. Okay. So there are two types of drugs which are acting. They are calcineurin inhibitors. They are coming as a cyclosporin and tacrolimus. The tacrolimus was actually called as when it was synthesized newly, when it was in the market. These drugs are coded. Whatsoever drug are there, they are all coded. And once it is approved, once everything is fine, then these drugs are given certain name on the basis of this the inventors, either structure based or on certain base. So this was tacrolimus was named as FK506. This FK is very important, we shall see it later. Okay. Now these are two. Calcineurin is one of the protein, we shall see the figure also. uh, these two are acting on one place. Sirolimus is also acting in similar fashion, just it has got a very slightly different mode, which we shall see. Then next kind of drug is they are corticosteroids. You have seen it earlier, we'll see in more detail again. Then cytotoxic drug. Now why you want to have cytotoxic drug, that again we'll discuss, because these drugs, that means too much cells are there. If there are too much WBCs are there, they are participating too much and doing too much job, then is a problem, because they are involved in that. We have seen that there is a their differentiation is increasing during immune mechanism. So if the differentiation is increasing, that means what? They are produced more and more. Okay. So in that case, if we have got certain drugs which are cytotoxic, they can reduce the formation of such, and therefore there will be a decrease in production of either antibodies or decrease in the cellular immunity. So most of these are called as antimetabolites. Now this antimetabolite word you should keep in mind. Anybody has heard about this antimetabolite word somewhere earlier? Know about it? Very good, Deepak. Very good. Where you read this folic acid reductase? Very good, very good. So you have finished chemotherapy? Yes, Akash. Dihydrofolate reductase. Where did you read this dihydrofolate reductase? Very good. So I should be proud of your batch. Before we plan about chemotherapy, you are almost in finishing stages. Fine. I want to know about antimetabolite then. What is antimetabolite? Taking time? Okay, I'll continue till time. I'll have eye on your answers. So these are what antimetabolites. Example of these are azathioprine, myclophenolate mofetil, leflunomide, methotrexate. Then other one are alkylating agents. Example is cyclophosphamide. Okay. Then immunosuppressive antibodies. There are a variety of antibodies are there. My question was different. What do you mean by what is the meaning of antimetabolite? Okay. Then next is immunosuppressive antibodies, which blocks the T cell surface molecules. They are involved in signaling immunoglobulins, and again in that there are a variety of these uh, that are anti-lymphocyte globulin, that is ALG, anti-thymocyte globulin. Okay, that is ATG, rho immunoglobulin, that is D immunoglobulin. Then MABs means monoclonal antibodies. So basiliximab, daclizumab, muromonab, which is particularly doing with CD3. Okay. Then interferon, thalidomide. These are some of the agents. We shall see them one by one. Okay. Whenever you will free, you can answer this antimetabolite. I'm not in hurry. Okay. Let me understand what you know about it. So it is a fungal polypeptide composed of 11 amino acids. It blocks by activation of T cell by inhibiting interleukin 2 production. It decreases proliferation. If we have seen interleukin plays very important role in proliferation and differentiation of T cell. So if it is not available, then there will be decrease in the proliferation and differentiation of T cell. If there are different decrease in the proliferation and differentiation of T cells, then no sufficient amount of cellular or humoral immunity will be there, and thus it will act as a immunosuppressant. So it binds with a typical receptor to which is called as a cyclophilin, or it is a protein. It is also called as a immunophilin also because of its involvement in the immune reaction. So this is an intracellular protein receptor wherein this acts. This cyclosporin and immunophilin complex that will inhibit calcineurin. It is an important phosphatase enzyme, the enzyme which breaks phosphate for the dephosphorylation of transcription factor NF8TC, that is nuclear factor of activated T cells. So this nuclear factor of activated T cell will not be dephosphorylated, and therefore interleukin synthesis will not be there, and thus it will suppress the cell mediated immunity. So this is what figure one can see how this happens. So when there are cells which are called as antigen presenting cells uh, in the center, top center, you can see. Then orange color one, these antigen presenting cells, they are modified because antigen antibody complex is there. It has bound to T cell receptor. Because of binding with the T cell receptor, uh, you will find that it causes calcium channel opening. It will cause activation of increase in the intracellular calcium. This calcium will act on the calcineurin, and after acting on calcineurin, which will convert inactive this nuclear factor for T cell, for activation of T cells, will be converted into active format, and this active will cause expression of IL-2 gene, that is interleukin 2 gene, and thus it will cause formation of interleukin, and interleukin will be produced. So this is what the mechanism is there. If it is blocked, then the next sequence will be blocked, and therefore interleukin will not be produced. And if interleukin 2 is not there, then it will cause reduction in the cell, or it will not participate in the cell mediated immunity. So it can be given orally or by IV. Normal doses are 25 to 100 milligram. soft gelatin capsule microemulsion. It is slowly and incompletely absorbed. So this is all pharmacokinetics. It's easy. Oral absorption is delayed by fatty meal. Okay. Microemulsion has got higher viability and it is not affected by food. It accumulates in blood, particularly in erythrocytes and lymphocytes, metabolized by cytochrome P450 system, mainly through bile into feces. About 6% is excreted in urine. Uses are organ transplantation like kidney, liver, heart, either alone or with other immunosuppressant agent like corticosteroids. Then in autoimmune disorders, that is around low dose is given, that is 7 mg per kg per day for endogenous uveitis, rheumatoid arthritis, active Crohn's disease, psoriasis, uh, then nephrotic syndrome, severe corticosteroid dependent asthma, and early type 1 diabetes. In that, it can be given. It can also be given in graft versus host disease after stem cell transplants. So these are what various uses it has got. ADRs are nephrotoxicity, which is increased by NSAIDs and aminoglycoside. We have already seen NSAIDs are having problem with many things which are affecting renal one during diuretics. We have seen it that they interfere with the mechanism and therefore it has got interaction with various diuretics also. Then during liver function should not be used in hypertension and hyperkalemia monitoring is essential. Potassium sparing diuretic should not be used with that. Then in hyperglycemia and in viral it should be used carefully. Other ADRs are, it can cause lymphoma, particularly those which are already having chances or higher probability, because then it can cause hirsutism, it can cause nephrotoxicity, neurotoxicity like tremors, gum hyperplasia, anaphylaxis reaction can be there. See, again, this is very strange. If somebody asks, and there is chance that people may not able to answer this. Anaphylaxis itself is a hypersensitivity reaction, which is because of the immune mechanism. Okay, and we are giving immunosuppressant drug. So why this? Because after IV, immediately it will act as hapten. It will cause binding with the uh, because of this binding with that hapten, it will behave as antigen. If it behaves as antigen, antigen antibody complex will be formed, and that is the very fastest. Anaphylactic is the fastest reaction, type 1 reaction we call in. So type 1 reaction is very fast, and because of that, before it can do the job of immunosuppression, anaphylactic shock can be there, and the patient may die with the immune reaction, because this is what IgG mediated very fast action is there. So there can be such kind of question in mind that why this happens. Then interaction, the clearance is enhanced by co-administration of the inducers of the enzymes like phenobarbital, phenytoin, rifampin, and because of that, if the enzymes are induced, that means metabolism increases. Because of increase in the metabolism, the plasma concentration decreases. Decrease in the plasma concentration will cause rejection of the transplant. Clearance of the cyclosporin is decreased when it is co-administered with the erythromycin or ketoconazole, grapefruit jute, which are causing inhibition of enzymes, or they compete with the enzymes. So it will cause accumulation and therefore toxicity. Then next drug is tacrolimus, which we have seen that it is called as, it was basically named as a research compound FK506. So it is a fungal macrolide antibiotic, chemically not related to cyclosporin, but they have similar mechanism of action. The internal receptor for tacrolimus is also immunophilin, but the in that we have seen it was a calcineurin, isn't it? Here the internal receptor is immunophilin and that is called as a FK binding protein or FKBP. Why FK binding protein? Because when tacrolimus was acting, when people tried to understand the mechanism, it was found that it is something different than cyclosporin. Cyclosporin was old. So they have given that this FK507 where it is binding, we'll call it as a FK506 binding. Slowly they removed 506 and the name came as a FK binding protein. Okay. So this is what typically FK binding protein is there, and that will cause inhibition of calcineurin. So you can see similar mechanism. If you see the previous one, it was cyclophilin. Uh, uh, this mechanism, if you can try to understand, uh, okay, I'm now see trying to show you the cyclosporin first. That is, it is binding to the cyclophilin, and because of this cyclophilin, it is acting on calcineurin. Okay. Now we have seen already this action. The next steps are same. While the tacrolimus is having another protein that is called as a FK binding protein. What FK means? FK506. So that will binding again, that will cause inhibition of calcineurin and next mechanism is same. So this is how these two drugs are acting, and because of that they are causing inhibition. Kinetics can given orally IV or topically also ointment for skin disorders, immune reactions. Oral absorption is variable and incomplete. It is reduced by the fat and carbohydrate meals. Half-life after intravenous is around 9 to 12 hours, highly bound with proteins and concentrated in erythrocytes. Metabolite by cytochrome P450 in liver, excreted mainly in the bile and minimally in urine. Again, same uses, that is organs and stem cell transplantation, prevention of rejection of liver and kidney transplants with glucocorticoids, atopic dermatitis and psoriasis. For that, I told you for skin immunological skin diseases, it is used. So in that case, it is used. Toxic effects, nephrotoxicity more than cyclosporin. Okay. Then neurotoxicity is also more. Hyperglycemia it can cause, and it can be very severe one, can cause a requirement of insulin. That means can affect beta cells directly, causes GI disturbances, hyperkalemia, hypertension, anaphylaxis. Again, it may feel strange why anaphylaxis. I already answered. No hirsutism or gum hyperplasia as compared to previous one, and the drug interaction similar to the previous one. So what are the differences? It is tacrolimus is almost up to 100 times more potent than cyclosporin. It has decreased episodes of reaction. It has combined with the lower doses, can be combined with the lower doses of glucocorticoids, but it is more nephrotoxic and if we compare. Next one is in that case is sirolimus. It is a macrolide antibiotic again derived from fungus. It inhibits FK binding protein and it forms complex which binds to a typical thing that is called as mTOR. So this is again a very popular one because it was not understood where this rapamycin is acting. When it was tried, the researcher that yes, it is causing immunosuppression, but the site is different than cyclosporin and site is different than the tacrolimus. So what it must be? So they have given it name as a mammalian target of rapamycin because sirolimus is also called as a rapamycin. or its earlier name as an antibiotic, it was actually made as an antibiotic, and later it was found that it is not actually antibiotic, it is a immunosuppressant drug. So mTOR is a serine threonine kinase essential for cell cycle progression, DNA repairs, and protein translation. And if this binds with that, then this will be affected. It blocks the uh, this one sirolimus or rapamycin of activated T cells from G1 to S phase. That is, cell cycle G1, G2, G0, and S is a synthesis phase. So, thus it causes anti-proliferative action during cancer. Again, it will be seen. It does not block interleukin 2 production, but blocks T cell response to cytokines. Means cytokines will not have a proper response to the cytokine. It will inhibit the beta cell proliferation and immunoglobulin production. Okay, and because of this, the action will be shown. So this is how difference is there. Sirolimus is acting, that is on FK binding proteins are there, which are similar to that of tacrolimus, and hence earlier it was believed that sirolimus and tacrolimus are having same mechanism of action. Later it was confirmed that sirolimus is different, tacrolimus is different. Okay, so this sirolimus and FKB complex will inhibit the mTOR, because of mTOR is mammalian target of rapamycin, and it will cause T cells will arrest in G phase. They will not go beyond G phase, so there will not be any cell division. And if no cell divisions are there, number of cells will be less. Again, this mTOR increases the translation of selected mRNAs that promote the transition from G1 to S phase of the cell cycle. And because of all these reactions, they will not allow the interleukin to act on the receptors, and if the interleukin 2 cannot act, it will not cause proliferation and differentiation as we have seen earlier. So it can be given orally, topically. It is reduced by the absorption reduced by fat meal. It is extensively bound to plasma protein. It is metabolized by CYP3A4 in liver. It is excreted in feces. Then immunosuppressive agents effects are there. Anti-proliferation action is there, and it is equal potent to that of cyclosporine. So it is used in solid organ allograft. It is used in renal transplantation alone or combined with other agents. Then it is used in heart uh, allografts. Then they are used in the halting graft vascular diseases. They are used in hematopoietic stem cell transplant recipients. Then topically with cyclosporin in uh, uveitis. It is synergistic with cyclosporin A. The toxic effects are, it causes hyperlipidemia, increase in cholesterol triglyceride levels. It causes thrombocytopenia. It causes leukopenia. It causes hepatotoxicity, hypertension, GI dysfunction. Okay, the next one are glucocorticoids, which we shall see next time. Any difficulties so far?